In this video, we want to integrate e to the negative 5x sine of 15x dx. The method we're going to do is tabular integration, which is an extended version of integration by parts. So the idea is you want to have a sine column, a derivative column, and an integral column. So for the derivative, you start off with your typical integration by parts. You're going to use e to the negative 5x. Although technically you can also use sine of 15x as well. Integral, I chose sine 15x, and the sine column is going to alternate between positive and negative. And we know that when you take a derivative of e to the negative 5x, it's always going to be a constant times e to the negative 5x. And then when you integrate sine of 15x, it's going to alternate, cosine and sine. So it's never going to be 0 for either of these two. So the trick here is, can we get it back of the form e to the negative 5x times sine of 15x? And the answer is yes. So after two steps here, we see that we have 25 e to the negative 5x, negative 1 over 225 sine of 15x. So the way the method works is we multiply the diagonals, and then we multiply this side, these two, and this will be inside the integral. Okay, so this is what we get. So keep in mind the sign. So this is like positive e to negative 5x. Think of this as like two minuses would make it a positive 5e to negative 5x. And then you multiply it by the negative 1 over 225 sine of 15x. Okay. Now we can simplify. So we have 5 over 225, 25 over 225. So that simplifies to 1 over 45 and 1/9. Now we can add both sides by 1/9 times the integral of e to the negative 5x sine of 15x to get 10/9 of that integral. So in order to solve for that integral, I have to multiply both sides by 9 over 10. And so this is my integral. Now I can factor out a negative 1 over 50 times e to the negative 5x, and what's left is 3 times cosine of 15x plus sine of 15x, and that is my answer.